This video explains how to conduct PIP testing on a sample. You'll begin by opening up Corsica and then selecting the PLX benchtop. Now you can begin with calibrations. I'll start with the machine setup calibrations, which the PIP will only need to go through when you switch out the stage between the room temperature PIP and the hot PIP. In that case, the program will prompt you to perform machine setup calibrations. However, it's also important to note that you should do it when it prompts you because if you wait, it won't prompt you again. In the case where you aren't being prompted, you would go ahead and go to Tools and then Machine Setup, and then you can hit Start. Now it'll prompt you to get the sample, which you can find in the drawer. You want the one labeled Working Distance and LVDT calibration. And then you can go ahead and place it onto the plate beneath the indenter. And now you're ready to start the machine setup. So essentially, it's going to perform several different calibrations, including working distance, LVDT, and profilometer distance calibrations. You're also going to want to go ahead and adjust the sample to make sure that the indenter tip and the LVDT aren't going to hit any of the previous indentations. And then it will sense the surface of the sample for some time before it's ready to begin the indentation. And then once it's ready to begin indentation, it'll ask you to check the position one last time. And again, you need to make sure that the indenter tip and the LVDT aren't over any previous indentations. And if that's the case, then you're ready to continue. And then it will begin indenting. And then while indenting, it'll create a load displacement curve. And then once that's done, it'll start searching for the center of the indent using the profilometer. And then once the profilometer is over the sample, this screen will pop up and you should leave the sample where it was after being indented. And then if needed, you can use these controls on the screen for finite movement. This is what it'll look like when the profilometer starts to search for the center of the indent. And then once the profilometer finishes, it will let you know that the calibration was completed successfully, which means you're ready to move on. And then the other important calibration is the profilometer calibration, which needs to be completed about every 4 hours. And again, the program will prompt you whenever it's time to perform this calibration. So you can begin this calibration by selecting the play button, and then it will prompt you to begin the profilometer calibration. You're going to start by getting the profilometer calibration sample. And this is what the sample looks like. Then you're going to place the calibration sample onto the plate, being very careful not to touch the profilometer. Then you're going to press start and make sure the depth matches the depth on the sample container. This is what the profilometry calibration looks like sped up, and that arm on the right side is the profilometer. Now, once the profilometer is over the sample, you're going to go ahead and adjust the sample so that the profilometer is as close to the indent as possible. Now the profilometer will calibrate for several minutes. Once the calibration is complete, this screen will appear and you can go ahead and select Finish. And then once that's all done, you're ready to remove the calibration sample and then go ahead and place in the sample that you're trying to test. It's very important when placing or removing a sample to be extremely careful not to touch the profilometer. Now you can go ahead and put the calibration sample back in its container and go ahead and put it away. And then when you're ready to begin the actual test, you're going to go ahead and press play again, and then browse the directory to find the correct folder for where you're going to put your information. And then once you've selected the correct file, you're going to go ahead and change the file name, and then make sure that these correct boxes are checked. You're also going to leave the saved material database blank, and then be sure to select the correct material type. This step is important because the material must be selected in order to assume a Young's modulus value that is taken into account in the iterative finite elemental program. And then you're ready to start the test. And then before placing the sample, it's important to note the parts of the indenter. In the center is the indenter tip, and then to the right of that is going to be the LVDT, which is what is used to sense where the sample is. When initially placing the sample, you're going to want to set it so that the LVDT is directly over the center of one of the samples. This way you can ensure the LVDT senses the sample and it stops. Now you can adjust the sample so that the indenter tip is over the center of the sample you're trying to indent, making sure that the LVDT is still touching the top of the sample. For this part, you want to ensure that the indenter tip is going to be 3 millimeters from the edges and 6 millimeters from any other indents. You also need to make sure that the sample you're indenting is at least 3 millimeters thick. Now that you've completed the final position check, you're ready to continue with the indentation. The test will now go on for several minutes, and this is part of what it looks like. Once the test is done, it will output a load displacement curve. And then here, the indent profile is taken and put into an iterative finite element program that uses the Vos stress-strain relationship to obtain stress-strain curves for the material being tested.
Once you've completed the test, a test diagnostic window will pop up, displaying the different parameters done in the test. For example, the indenter tip radius, the parameters of the Brinell hardness test, the target and achieved load of the indentation test itself, other parameters for the profilometry detailing the surface tilt, surface roughness, and isotropy, which shows if the hardness of the material in one direction is more or less than the other direction. The test statuses will be yellow or red if something went wrong, but in this case, everything was okay. Before you click Finish on the pop-up window, make sure to click Transfer to Data. And as you can see, the stress-strain curve, the indent profiles, the Brinell hardness test, all pop up in the graph. And then you want to export, PDF export, and leave all those options checked. And click Export, and you have to wait until this pop-up pops up saying it was successful. And for the Excel sheet export, you want to click Data Export, make sure everything is selected, and click Export. And as you can see here, you can go through the load displacement curve to see the different indents. The first one was blue, the second one was a yellowish color. And you can look at the profilometer alignment check, the anisotropy check, and the Brinell hardness test.
And now you're all done, but if you want to start another test, you can just hit the play button and a new prompt will pop up. Otherwise, you can X out of the program, which should also shut off the PIP.